this video, I'll show you how to use the EZ system, which is technically the IUPAC system, and putting the stereochemical designator in front of the name to either the E or the Z. And we'll see that technically you can't use cis and trans in some cases, so that's why you have to rely on the EZ. Before we start, I would like you to read section 5.2c, that's on pages 188 to 190. Since cis and trans isomers are different compounds from each other, as we've seen in previous videos, with different properties, they have to have different names, so that if you've separated the cis from the trans, you have to put one in one bottle and one in a different bottle, then you have to have a label, you have to have a name to put on the label so that whoever's going to use those compounds will know which one is which. So that's why it's important to have that as part of the name. Some alkenes have cis and trans isomers that are easily distinguished from the cis from the trans. Here's a couple of examples. This is obviously trans. The two hydrogens are trans from each other, and the methyl group and the ethyl group are trans from each other. The IUPAC name for this would be 2-pentene, because it's 5 carbons in a row, double bond at carbon number 2, so it's 2-pentene. And you could put trans in front of that name, and then it would be a perfectly fine name. Again, technically it's not IUPAC, but most chemists would go ahead and use that just for fun. Let's go ahead and take a look at the three-dimensional structure of that compound. So there it is. It's 2-pentene, and you can see that the ethyl group and the methyl group are trans to each other, as are the two hydrogens. This, on the other hand, is cis 2-pentene. Obviously, the methyl and the ethyl group are cis to each other. The two hydrogens are cis to each other. Again, these are two different compounds, as indicated by their different boiling points and different melting points. Let's just take a quick look at that compound. It's three-dimensional structure. There it is. Obviously, the ethyl group and the methyl group are cis to each other on that double bond same side, and the hydrogens are cis to each other on that side. In this case, the cis or trans prefix is fine, and most people would go ahead and use that. But some alkenes are not quite so simple to tell. For example, this one would be 3-methyl 2-pentene. I've drawn the one in which the two methyl groups happen to be trans to each other, and the methyl group happens to be cis to an ethyl group. So would this be called trans because the two methyl groups are trans to each other, or would it be called cis because the longest chain goes through this cis kind of configuration? In other words, the biggest group on this side and the biggest group on this side are cis to each other. So would you call it trans, or would you call it cis? Well, this is one where it's not quite so obvious, so we use the EZ system, which I'll be explaining to you here in just a minute. And again, just for fun, let's take a look at the three-dimensional structure of that molecule. And there it is. So, methyl groups trans to each other, ethyl group cis to the methyl group. So, let's learn about the IUPAC system, the EZ system. So we use the Coning-Gold-Prelog priority system, which we learned back in Chapter 3, Stereochemistry. We used it to prioritize groups on a chiral carbon so that we could give the molecule a R or an S prefix. Same idea here. It's actually simpler with alkenes because you only have to look at two different groups and decide their priorities. So what you do is, as indicated here, you prioritize the two groups on each of the alkene carbons. So obviously in this carbon you have a methyl group and hydrogen. On this carbon you have a methyl group and an ethyl group. Two different groups on this end, two different groups on this end. So go ahead and prioritize which is higher priority here and which is higher priority here. Let's move on to the next slide. Obviously, methyl group is higher than hydrogen, so this is 1 and this is 2. And obviously, ethyl group is higher than a methyl group, so this is 1 and this is 2. Just to review, carbon is heavier than hydrogen, so that's why this one's number 1. And carbon with one carbon attached to it is heavier than carbon with no carbons attached to it. So this is higher priority. So again, the two higher priority groups are cis to each other in this case, and so we call it Z. Now Z stands for zusammen, which is the German word for together, and if it were E, that stands for the German word entgangen, which means opposite. So this double bond is called Z, so we can now give it the complete name, Z 3-methyl 2-pentene. The Z goes out in front, in parentheses as a capital letter, just like R and S does in chiral compounds. So, what I would like you to do is give the E or Z configuration for this double bond and the E or Z configuration for this double bond. This says give the complete IUPAC name, but you don't actually know how to name ethers and or alkyl halides, so just tell me if this one is E or Z, and tell me if this this one is E or Z. Looking at these two groups, which is higher priority, looking at these two groups, which is higher priority, and then in this case, bromine or this propyl group, which is higher priority, methyl or ethyl, which is higher priority. So go ahead and do that, and I'll move to the next slide and show you the answers. Okay, so this one is E, 3-methoxy, 2-phenyl, 2-hexene. And again, we don't know how to name those yet, but I think you can probably figure it out with too much trouble. But the point is that this is E. So why is this one E? Because of these two groups, the phenyl group is highest priority, higher than a methyl group. And in these two groups, the methoxy group is higher priority. Now that may surprise you, but just remember it's the weight of the atom that we're looking at. So oxygen is heavier than carbon, oxygen being 16, carbon being 12. So this is higher priority on this end. This is higher priority on this end. They are across from each other, and therefore it's E. A little bit more complicated here because this is one of those cases where the longest chain is drawn out in a straight line. But I think you can see that the bromine would be cis to the ethyl group here, and the propyl would be cis to the methyl group here. So what's higher priority, bromine or propyl? And the answer is bromine, because bromine is heavier than carbon. And which is higher priority here? Well, we've already seen ethyl is higher priority than methyl. So the ethyl group is higher priority, and the bromine is higher priority. Those are cis to each other, and so this is a Z molecule. Again, the full name is 4-bromo-3-methyl-3-heptene, and I think that is obvious why it's called that. And that ends the video for today. Thank you.